welcome back again to a new lecture. And in this lecture we will start a new topic from your textbook, that is chapter number 7. The name of the chapter is Introduction to Triangles, right? In the chapter 6 we have discussed about the triangles and its various properties, right? We know that a triangle is a polygon having how many sides? Having 3 sides, right? And the 3 sides are AB, BC and CA. It has 3 vertex, right? Vertex A, vertex B and vertex C. As well as it has 3 angles. Angle A, angle B and angle C. So a triangle has such phenomenon, and according to the theorem number 6.7, we have discussed that the sum of 3 angles of a triangle is equal to 180 degree. It means if you add these 3 angles, then you will get 180 degree. Similarly, if we extend this side or this base BC to a point D, then we will get an exterior angle, and this exterior angle is equal to the sum of 2 interior opposite angles, like this angle plus this angle. Okay? So this angle is equal to this angle plus this angle. This is the theorem number 6.8. So these are the various ideas and properties about triangles. But in this lecture we will discuss about a new term, okay, that is known as congruence. Okay, so our today's topic is congruence. So let's see what is congruence. So the term is congruence. So let us first understand the meaning of congruence. What does it mean? Okay. So literally the meaning of congruence is there are 2 figures. If in 2 figures they have same shape and same size, then these 2 figures are known as congruence. Okay. So let us write the definition first. 2 figures are said to be congruent if they have same shape and same size. Okay, this is the literal definition of congruence. So in order to be congruence, the 2 figures must have same shape and same size. Okay, it is the best meaning. Now, as you can see, there are 2 terms, shape and size. The shape and the size have different meaning. They don't have same meaning. What is the meaning of shape and what is the meaning of size? Shape means the type of figure. Right? Shape means the type of figure. Okay, figure means you can take a polygon. Okay. Now, what is the example of type of figure? For example, suppose this is the example of a triangle. This is the example of a square, or you can say quadrilateral. This is the example of a hexagon because it has 6 sides, right? This is the example of also a quadrilateral. Yes or no? Yes. Now, this is the example of a pentagon. Now, here we see 5 figures. Now, among these 5 figures, as you can see, this figure is known as quadrilateral, this figure is known as quadrilateral. So these 2 figures have same shape. Shape means type of figure. So these 2 figures are of same shape. But if you compare this figure and this figure, this is a triangle because it has 3 sides, but this is a quadrilateral as it has 4 sides. So these 2 figures are not same shape or do not have same shape. If we compare this figure with this figure, then also these two figure don't have same shape. Okay, this figure also they don't have same shape because it is a quadrilateral, it is a hexagon. If you compare this figure with this figure, it has 6 sides, it has 5 sides, so they have different shape. So this is the meaning of set. Set means the type of figure. Okay, if we consider this with this, does these two figure have same shape? No, they don't have same shape because it is a circle and it is a triangle. How they become same? No, they don't have same shape. Understood? So this is the meaning of set. Now coming to the side. What is the meaning of side? See, suppose this is a triangle. Okay. This is also a triangle. Now this is also a triangle. So there are 3 triangles, right? Suppose name them ABC, DEF, GHI. In this triangle, let's see, this side is 6 cm, this side is 7 cm, this side is 9 cm. Right? In this triangle, this is 4 cm, this is 5 and this is 4.5. Okay? Now, in this triangle, suppose this is 7, this is 6 and this is 9. Now, tell me whether these two figures have same shape or not. Yes, they have same shape. I am talking about shape, not size. I am talking about shape. It is a triangle. It is also a triangle. It is also a triangle. So these 3 figures are of same shape. But did they have same size? Let's see. If you compare this triangle with this triangle, right? Then in this triangle, this side is 6, this side is 7, this side is 9. But in this case, all sides are completely different from this triangle. Okay? Similarly, if you consider this triangle with this triangle, it has 4, 4.5 and 5 as side, but it has 7, 9 and 6 as sides. So these two triangles, though they have same shape, but they do not have same size because their sides are not equal length. So the size refers to what? It refers to the dimension. It refers to the dimension. Okay? For example, if this is a square, okay, of side 4 here, then this is another square. This is another square. Its side is 2, 2, 2, 2. Its side is 4, 4, 4, 4. Okay? Now, compare this quadrilateral or this square with this square. Now, in this quadrilateral, okay, in this square, the dimension means the length, the breadth, or you can say the radius, or you can say the side, whatever. Okay? Dimension means length, breadth, height, radius of a circle, sides of a triangle. Okay. So, if we compare this two figure, then in this two figure, it has the side 4, it has the side 2. So, they don't have same size. Okay. Similarly, if you compare these two figure, now it has side 4, 4, 4, 4, it has also side 4, 4, 4, 4. Then these two figure will be of same size. Okay. Now we cleared the idea about the shape and the size. So in order to be congruent, two figures are said to be congruent if they have same shape as well as they have same size. The two conditions must be satisfied in order to be congruent. Okay. So let's draw some figure and verify whether they are congruent or they are not congruent. Okay. Right, so let's take two examples first. Question number 1. Compare this figure with this figure. Now the question is whether these two figures are congruent or they are not congruent. See, In order to be congruent or not congruent, we have to first verify whether they have same shape. First condition. See, does these two figures are same shape? No, it is a circle, but it is a triangle. They don't have same shape. They are completely different. So this triangle is not. So this circle is not congruent to this triangle. Okay. So there is a symbol for congruency. What is the symbol? Like this, and this. How? This equal symbol, then a wave symbol. This is the symbol for congruency. Now this circle is not congruent to the triangle. So this. Understood? Next example. Of radius 3, it has radius 4. Now tell me whether these two figures are congruent or they are not congruent. In order to find such things, we have to first verify whether they have same shape. See, it is a circle, it is also a circle. So they have same shape. The first condition is satisfied. Now coming to the second condition, that is size. See, whether they have same size. It is of 3 cm, but it is of 4 cm radius. It seems to be a smaller circle. It seems to be a larger circle. So their sides are not equal. Hence, these two figures are not congruent. Understood? Next example. In question number 3, suppose it is a triangle having one of its angle is 90 degree, this side is 3, this side is 4 and this side is 5. Another triangle having angle 90 and this side is 4, this side is 3, this side is 5. Now we have to verify whether these two figures are congruent or they are not congruent. Now talk about their shape. Since both are triangle as well as both have one angle 90 degree, that means these two triangles are right angle triangles. So they have same shape. Understood? Next, whether they have same size, that means whether the sides of two triangles are equal or they are not equal. Let's see. This side is equal to this side, this base is equal to this base, and this hypotenuse is equal to this hypotenuse. Hence, these two figures have same shape and same size. That's why these two figures are congruent. So in this way, by judging their shape and size, we can verify whether the two figures are congruent or they are not congruent. Okay? But there is a very easy method in order to differentiate whether the two triangles or two figures are congruent or not. What is that procedure? See, suppose this is a triangle, right? This is a triangle. Okay? And this is another triangle. Now tell me whether these two triangles are congruent or they are not congruent. Since it seems to be that this side is longer side, but this side is smaller side. This base is smaller, but here it is very large. Yes or no? So literally these two figures seems to be not congruent, because though these two have same shape, though they are triangle, but they do not have same size. So we can say yes, they are not congruent, but actually they are congruent. Why? Because if you put this triangle here and another triangle, rotate it and fix on it, then you can see this triangle completely covers the second triangle. See? It seems to be only one triangle or not? See? The first triangle completely covers the second triangle. That is why these two triangles are known as congruent. So the another way of finding the congruency is that you have to put one triangle over another triangle. And if this triangle completely covers another triangle, then these two figures are congruent. Like this. Suppose this is one of my hand or a palm. Now put this palm over this palm. Now see. How many palm you can see here? See, Here only I can see one palm. Yes or no? This palm is completely covered by this palm. Yes or no? Yes. See? Similarly here also. This palm completely covered this palm. So these two figures, these two palms are congruent. Similarly, these two triangles are congruent because if you rotate this triangle like this and cover this, then this triangle completely decides on another triangle. Understood? Similarly, if we talk about this figure, okay, and this figure, whether these two figures are congruent, yes or no? See how many sides it has? 1, 2, 3, 4, 5. It is a pentagon. It is also a pentagon. So these two figures are pentagon, but they seems to be different sides. Yes or no? Yes, but actually they are congruent. How? Let's see. If I put this figure here and another another pentagon over here, then you can see this figure, this pentagon completely covers the second pentagon. Yes or no? Similarly, this pentagon completely covers the second pentagon. Hence, these two figures are congruent. Okay? So, in order to find the congruency, you can use any procedure. Either you can see their shape and size, or you can put one figure over another figure. But this is not mathematically proven, but you can prove it. Okay? So, next we will discuss about congruency of triangle. Okay? So, next thing is congruency of triangle. Congruency of triangle, right? So, how the two triangles are congruent, we will discuss here. As I have told you, the two triangle will be congruent if the two triangles have same shape and same size. This is the literal meaning, right? So, two triangles will be congruent if the two triangles have same shape. If two triangles have same shape and same size. Understood? So this is a triangle. This is another triangle. Now this triangle, this angle is 90. It is 90, 2, 3, 2, 3, 4, 4. Now as you can see, these two are right angle triangle. So their shape are equal, and these two triangles have all the sides equal. Yes or no? Yes. So these two triangles are congruent triangle. Okay. So this is the definition of congruency of triangle. In another way, you can prove like this. If one triangle put over another triangle such that it completely covers the another triangle, then these two triangles are congruent. Or there is another definition. What is the definition? See, if all the sides and all the angles of one triangle are equal to another triangle. If all the sides of one triangle and all the angles of one triangle is equal to the sides and the angles of another triangle, then the two triangles are two triangles. Symbolically represented are congruent. Okay. For example, if in this two figure this angle is 60, 60, 60, 60, 60, 60. Okay, and this side is 5, 5, 5, 5, 5, 5. Now, in this two figure, the two triangles have same side 5, 5, 5. Okay, so it is a equilateral triangle. It is also have side 5, 5, 5. Okay, and they have also angle 60, 60, 60. Here also angle 60, 60, 60. Then these two triangles are known as congruent triangle. So in order to be congruent, the two triangles must have same side and they must have same angle. And there is a word and, not or. Two conditions must be satisfied. Not like this. Suppose this is also a triangle. This is 60, this is 60, this is 60. 6, 6, 6. Do these two triangles are congruent? No, they are not congruent. Why? Because though they have same angle, 60, 60, 60, but they have different side. 5, 5, 5, here 6, 6, 6. So these two triangles are not congruent. Okay, so these two condition must be satisfied in order to be congruent. Okay, so let us take some examples so that it is easy to understand. So let us take the first example. In the first example, as you can see, there are two figures and we have to verify whether these two figures are congruent or they are not congruent, right? So in order to prove it, first we have to show whether they have the same shape or not. Then we have to prove whether they have same size or not, right? So, as it is also a triangle, it is also a triangle. But the different thing is that this triangle is like this and the hypotenuse faces towards this direction. But in this triangle, the hypotenuse faces towards this side or this direction. So though they are triangle, but they are facing towards opposite direction. They do not seem like to be equal. Yes or no? Yes. So we can say that these two triangle or these two figure have the same shape. But actually, these two triangles are of same shape. Why? See. If you take this triangle like this and another triangle like this, okay, like this, though this two triangles seems to be different shape, but if you put this triangle here and rotate this triangle like this, okay, see, the triangle is like this and you have to rotate like this and put this triangle over this triangle, then what you see? You see the first triangle completely covers the second triangle. See, from this side also you can see this triangle completely covers another triangle. And you know, if one figure completely covers another figure, then the two figures will be congruent or the two figures will have same shape. So, though they do not seem like to be equal shape, but actually they are equal if we put one triangle over the another triangle. Okay? So let's see. So let us write first. If we put this triangle, DEF triangle, over this triangle, ABC triangle. See, I started writing like this, DEF and then ABC. Why I am not writing like this? ACB triangle. See, there is a difference. ABC triangle means this triangle. SCB triangle means also this triangle. But why I did not write this triangle? I write this triangle. Why? The reason is that, see, when I started writing this triangle, from which point? From this vertex. And this is a vertex at which this side 6 cm and this side 3 cm will meet. At this vertex, this side and this side meets. Similarly, if I started writing from this side or from this point, but here this is a vertex where 6 cm and 5 cm side will meet, but here 6 and 3 cm side will meet. That is why we cannot write or we cannot name a triangle from this triangle. Okay, we have to correlate the two triangles. That is why I started writing from the point A. See, This is the vertex and this is the point where this side 3 centimeter and 6 centimeter meet. Similarly, it is a point where 3 centimeter 6 centimeter will meet. So I first write A. Okay. Then here I write E. Okay. E is a point where this 3 centimeter and 5 centimeter meet. Similarly, B is a point where 3 and 5 will meet. That is why I write B, not C. I can't write C because C is the vertex where 5 and 6 centimeter will meet. Understood? Similarly, lastly I write F. F is a vertex where 6 and 5 will meet. Similarly, C is the vertex where 6 and 5 will meet. That's why I write ABC triangle, not SCB triangle. You have to keep in mind this thing. Okay. So, wherever this triangle put over this triangle, then what will happen? Then, see, this is the triangle, right? And this is another triangle. I rotate it like this and put this triangle over this triangle. Then what you see? You see that this base completely covers another base. This hypotenuse completely covers another triangle's hypotenuse. This perpendicular height completely covers another triangle's perpendicular height. Yes or no? Yes. So whenever you put this triangle over this triangle, then what will happen? See, this is 3 centimeter. Then this is 3 centimeter. We rotate it like this and put over this. So this side is completely covered by this side. Yes or no? Yes. This side is completely covered by which side? This side. Yes or no? Yes. Okay. So you can write DE covers, or you can write corresponds to which side? AB side. AB side or BA side? What do you have to write? AB or BA? Tell me what you have to write. We write here B. So here also you have to write AB, not BA. Okay? Understood? Second, this base completely covers this base. See? This base completely covers this base. Understood? So EF covers or corresponding to this base. Tell me, I have to write CB or BC? Both are same. CB is equal to BC. But what is to be the proper order of writing? I started here like EF. E is the point where this 3 and 5 meet. So here you have to choose a point where 3 and 5 will meet. B. So B first, then C. Understood? Similarly, AC, this is DF, covers or corresponds to DF is equal to AC. This side completely covers this side. Okay, AC, not CA. So what we find? We find that whenever this triangle put over this triangle, then this side covers this side, this side covers this side, this side covers this side. And also this vertex F is covered by, suppose this is a vertex, this is a vertex, this is a vertex. Now you can see this vertex is covered by this vertex, and this vertex covers this vertex, this vertex covers this vertex. So vertex E, okay, vertex E covers which vertex? Vertex B, because E is a point where 3 and 5 meet and B is a point where 3 and 5 meet. So E covers B. You can write like this: E covers, and D covers which side or which vertex? A, because D is a point where 6 and 3 meet, A is a point where 6 and 3 meet. So D covers A. Okay, and F covers which point? B or C? Which point? C point, because F is a point where 5 and 6 meet and C is a point where 5 and 6 meet. So F covers C. So F covers C. And also third condition, this angle, angle D, covers this angle, angle A. Angle D covers angle A. This angle covers this angle, angle E covers angle B. And this angle covers this angle. So angle F covers angle C. Understood? So this triangle is congruent to this triangle. Okay? Hence these two triangles are congruent. And how can you write this? You have to write the triangle ABC is congruent to the triangle. Which triangle? This triangle. But how can you name them? You can name like FED triangle, or you can name like EDF triangle, or you can name like DEF triangle. Then which one is correct naming or correct order? See, you have started from the point A. The vertex A is the meeting point of 3 and 6 centimeter. So here D is the meeting point of 3 and 6. So the naming should start from D, right? Then B is the meeting point of 3 and 5. So E is the meeting point of 3 and 5. So after D you have to write E, then you have to write C. C is the meeting point of 6 and 5, right? Similarly F is the meeting point of 6 and 5. So then F. So you have to write that triangle ABC is congruent to triangle DF, not FED triangle. Okay.